This video is going to show you how to perform a two-sample t-test. So I'm going to go and open up my data. I'm going to the OpEx data, and I'm going down to two-sample t shipping. So I've got data. OpEx has done a couple of things here. One, it's arranged the data essentially in one column. You can see right here in column C1, it tells you the data is shown in one column C2, with the subscripts in C3. So this is the shipping time in column C2, and column C3 shows the route, of the new route and the old route. According to the OpEx book, the scenario being presented here is the shipping time to move goods to Japan, time and days on the new route versus time and days in the old route. And what we've been doing is comparing the averages from the new route to the average from the old route. Over here in column C4, it tells us that these rows are unstacked. So essentially taking the data from column C2 and C3 and separated them. So I have data for the new route in column C6, data for the old route in column C7. Then over here, it's giving me summarized data. It's showing me how large the sample size is for the new and the old routes, what the mean is for the new route versus the mean for the old route, and what the standard deviation is. We're going to go real basic, just start real basic, and just use the data in columns C2 and C3. So I'm going to go to Stat, Basic Statistics, two-sample T. We're going to be comparing the averages. So it defaults to both of the samples are in one column, and they are in one column. The values from the new route and the old route are all in one column. Those samples are in C2. So what it's asking here is the output, the Y, the amount of time it takes to ship. And that's asking for the X. What are the groups that we're comparing against each other? We're saying that the time it takes to ship our goods depends on the route. Remember, Y is a function of X. The time it takes is a function of the route. And for the data in C2, the route is in C3. So I'm going to click on OK. Gives me my output right here. Tells me my what I'm doing a two-sample t-test and confidence interval for time in days, which is the name of the column, versus route. Gives you some information about the test that I'm doing. So mu sub 1 is the population mean when the route is new, and mu sub 2 is the population mean when the route is old. It's comparing the difference. So mu sub 1 minus mu sub 2 is what it's looking at. My descriptive statistics, I have 20 rows of data for the new route, mean is 32.12. I have 25 rows of data from the old route, the mean is 34.35. We're going to come back to this estimate for difference. We'll come down here to the test. The null hypothesis, H sub O, is mu sub 1 minus mu sub 2 equals 0. So when we talk about what our null hypothesis says in English, in words, we say there is no difference. The null hypothesis, there is no difference in the average time it takes to ship goods via the new route versus the average time it took to ship goods via the old route. There is no difference. So if we subtract mu sub 2 from mu sub 1, the difference would be 0 because there's no difference. X minus X equals 0. The alternate hypothesis is that there is a difference. There's a difference in the average time it takes for the new route and the average time it takes for the old route. So the alternate hypothesis, H sub 1, says mu sub 1 minus mu sub 2 is not 0. If they're not equal, then when you subtract one from the other, you get a number different from 0. So it's calculating that difference between the average times. The p-value I get is 0.03. If you remember, our alpha is at 0.05. So this p-value is low. The p is high, you keep the guy, fail to reject the null hypothesis. If the p is low, the null must go. So reject the null hypothesis and conclude there is a difference in the average time it takes to ship goods to the old route versus the new route. Let's look back here at this estimate for difference. So remember, this test is essentially subtracting the average of the new route, it's subtracting the average of the old route from the average of the new route, right? And if that difference is 0, then there's no difference, and we would reject the null hypothesis. If there is a difference, if there's no difference, we fail to reject. If there's a difference, we reject. This estimation for difference, so it's estimating what that difference is between mu sub 1 and mu sub 2. And the estimate, the 95% confidence interval for that difference for the population is between -4.2 and -0.2. The actual difference between those two means is -2.237. The confidence interval goes somewhere from -4.2 to -0.2. That confidence interval does not include 0. It goes from -4.2 to -0.2. 0 is not between those two numbers. So Minitab concludes that there is a difference, and we have a low p-value. Now I can also do this test with the unstacked data. We did it with the stacked data where all the values were in one column. Now if I go to edit last dialog and I choose each sample is in its own column, and I get sample 1, new column, sample 2 in the old column, click on OK, and I get the exact same results. So 2 ways of doing the test depending on how your data is arranged. Most of the time, you're going to have data, in one column. All the both groups will be in one column. If they're not, if they're in separate columns, you can still do the same test. You just choose a different default right here, and you say each sample in its own column. But typically, it's going to be in one column. We can also do this data with summarized data. So for sample 1, we know that the sample size is 20. The sample mean is 332.115. Standard deviation is 3.465. Sample 2, the old route, sample size is 25. The mean is 34.52. Standard deviation is 3.115. Okay. Again, get the exact same results. It's a lot simpler when your data is arranged in one column with the subscripts or the groups, the names of the two groups in another parallel column. So that's a 2-sample t-test. Thanks very much.